Your data center's cooling depends on getting data fast. But when you start wiring the sensors, which protocol do you choose? RTU or TCP? Because the simple fact is that this environment with its dense equipment, high electrical noise, and long cable runs will severely test your protocol's reliability. And the one you choose directly determines how reliable your monitoring is. So today we're breaking down exactly where Modbus RTU works best, why Modbus TCP is essential, and how the best data centers actually use both to keep the system running. So Modbus RTU is the one most people recognize. It runs over RS-485, it's simple, it's deterministic, and honestly, it's one of the most durable communication methods still used in industrial environments. I mean, there's a reason why so many cooling and environmental sensors still rely on it. Rack level temperature and humidity nodes, airflow sensors, leak detection modules, devices that are almost always deployed in large groups tend to be built around RS-485 hardware. Even a lot of power meters used on cooling loads, like the kinds you'd see feeding data into a monitoring loop, still communicate over RTU because serial is stable, predictable, and extremely good at handling electrical noise. If you've ever installed monitoring under raised flooring or along a cooling loop, you already know why RTU is still everywhere. Most of these sensors sit close together, they only need to transmit small packets of data, and they stay in the same place for years. RS-485 is perfect for that kind of deployment. It's dependable, it's cheap, and it doesn't need a switch, router, or any complex networking structure to work. That's why environmental loggers and leak detection hardware, even modern versions like our DL series or ISN series, still offer RTU as a standard interface. They're purpose-built for tightly grouped sensing zones. But as soon as you move beyond the sensor level, your facility starts to look very different. Your DCIM platform doesn't run on serial. Your SCADA system doesn't run on serial. Your visualization dashboards, your centralized alarms, your analytics, they all run on Ethernet. And this is where Modbus TCP becomes essential. Modbus TCP is just Modbus RTU running on Ethernet without routing information added. But that one difference changes everything. Instead of pulling devices one at a time over an RS-485 chain, TCP allows your monitoring software to query devices in parallel. It lets you scale across rooms and buildings. It lets you pull in thousands of data points per second without overwhelming the network. And because it's Ethernet, you get built-in long-distance capability, redundancy options, and support for remote access that would be impossible on RTU alone. This is why most modern data centers lean heavily on TCP for higher level monitoring, things like heat mapping, airflow balancing, chilled water system visibility, and real-time analytics. When operators need to see cooling performance across an entire facility instantly, Modbus TCP gives them the speed and bandwidth needed to do it. Many of the Ethernet I/O modules and controllers used in these systems, including compact devices like the ET7000 series or edge controllers used for automation, accept TCP for this exact reason. They're designed for centralized visibility. Now, here's where the real engineering challenge comes in. Data centers never run on just one protocol. You walk into any facility and you'll see a mixture of serial leak detection devices, serial humidity sensors, serial power meters, Ethernet-based controllers, cloud-connected monitoring tools, and dashboards that expect everything to arrive over TCP. The environmental layer is still serial, but the supervisory layer is Ethernet. And the problem is that they have to work together. But replacing all those RTU sensors isn't an option. They work, they're stable, and swapping them out would cost a fortune. So instead of removing them, engineers just bridge them. They take the Modbus RTU data from RS-485 devices and convert it into Modbus TCP so the facility's monitoring platform sees everything as a modern Ethernet system. And this is where Modbus gateways come in. A gateway sits between the legacy RTU loop and the Ethernet network. On one side, it speaks Modbus RTU to the sensors, and on the other side, it exposes the same data over Modbus TCP to your DCIM, SCADA, or monitoring platform. Everything stays where it is, your leak detection modules stay serial, your environmental sensors stay serial, but the facility gets full modern visibility. Gateways like the TGW series are designed exactly for this purpose. Take in serial data from the field, move it into Ethernet cleanly, and let the software layer treat everything as if it were native TCP. In practice, this hybrid architecture shows up everywhere. Underfloor leak detection cables feeding serial into an Ethernet dashboard, rack level environmental sensors running on RS-485 loops that feed into a TCP backbone, cooling tower sensors and flow meters that still speak RTU but need to integrate into a centralized monitoring environment. Even power meters tied into cooling systems often run serial in the field but report through TCP once aggregated. And if any of that data needs automated logic like triggering alarms, switching equipment, or running conditional routines, edge controllers such as WISE units can sit on the TCP side, interpret the data coming from gateways, log it, and react to it automatically. So when engineers ask, should I choose Modbus RTU or Modbus TCP for my cooling and environmental monitoring system, the answer is actually pretty simple. You use both, but in the places where each one makes sense. RTU belongs in the field level where sensors are local, distances are short, wiring needs to be simple, and the environment is noisy. While TCP belongs at the supervisory level, where data needs to be accessed remotely, pulled quickly, visualized centrally, and integrated with modern platforms. And that hybrid approach is exactly how real data centers are being built and upgraded today. You keep the stable, proven serial devices where they're strongest, you use Ethernet where it actually provides value, and you bridge the gap with gateways so the entire system behaves like one unified monitoring architecture. If you're working on a data center project and you need to bring RTU-based environmental or cooling data into a modern TCP monitoring environment, take a look at our communication modules, Modbus gateways, and automated tools at icp-usa.com. Or you can reach out directly at sales@icp-usa.com. And if you want more engineering breakdowns like this one, make sure you subscribe because we post new videos every single week to help you build smarter, more reliable systems.